Our quiz number 13 is using spherical coordinates to express pieces of fruits. Let's take a look at problem number 1. Problem number 1, we start with a honeydew. Let's assume that the honeydew is perfectly spherical. And the first thing we want to do is we want to cut the bottom out. So let's cut the bottom out. There's the bottom being cut out. So now we just have the top part of the honeydew. Next thing we do is cut it along the XZ plane so that back part disappears. Now we have a quarter of a honeydew, and finally we're going to cut the back part out, so now we have only an eighth of a honeydew left. Okay, so let's assume that this is our honeydew. Let's see, we can clear it up a little bit to make it clear that there's a hole in the middle here. And this is it. So let me just put some parameters, extra parameters here. We have our radial distance would be 2, just to make things easy. And then the inner hole over here, the radial distance would be 1. And then I think you have everything else you need. So let's figure out what happens for rho, for phi, and for theta. And this is our honeydew. So that's problem number 1. Problem number 2, we're taking a look at some orange slices. So let's say we have a spherical orange, perfectly round, perfectly spherical, with a radius 1. And let's say each slice of the orange, each little segment, has an angle of pi over 6. So let's just take a look at one of them. So let's take all the oranges apart and make them all disappear, except for one slice, one segment of the orange. Alright, so this has an angle of pi over 6, and let's say it has a radial distance of 1. And so let's figure out, you get to figure out what rho is, what phi is, and what theta is equal to. And this is a little piece of our orange slice. For problem number 3, we're going to look at a watermelon. Let's take a look at a spherical watermelon. This time we're going to slice it from the bottom. Directly from the bottom, there's a 45-degree angle that we're going to make. So let's take that piece out, and what we're interested in is the remaining volume, that little bit of a watermelon here. So what are we looking at here? If we were to draw the negative z-axis straight down, the angle that this makes with the negative z-axis is pi over 4. And let's say a watermelon has a radial distance of 2. And I think that's all we need to know about this, and you should be able to express this solid, or this solid in terms of rho, phi, and theta. And this is our watermelon. Problem number 4, we take a look at a cantaloupe. And first thing we need from the cantaloupe is from this particular cantaloupe, notice where the X and the Y and the Z axes are. We're going to cut this along the XZ plane and then take the front part out. So we cut this cantaloupe out and that disappears. And then what we're going to do here now is cut at a 45-degree angle in a spherical direction on the top and on the bottom. So what we're going to do is we're going to take those out. And then what we have left is a solid that we're going to integrate over. And so we want to be able to express this in terms of rho, phi, and theta. So one thing we should note is that the outer radius is 2, the inner radius is 1, and this thing was cut with an angle of pi over 4 from the positive z-axis, and it was also cut with an angle of pi over 4 from the negative z-axis. So the question is, what is our rho, our phi, and our theta? And this is my best attempt of that cantaloupe cut. It probably needs to have been cut a little bit more of an angle higher than what we have here. But this is what the picture should look like, and this is what my cantaloupe looks like. For our last question, we're going to go back to our watermelon problem. Again, a spherical watermelon. And remember that bottom that was taken out? We're actually going to take that out completely. And then this time we're going to keep the top. Last time we threw the top away, but we're going to keep the top. But not only that, we're also going to chop the top part off. So let's take that top part off. And so here is the remaining solid that we're looking for, which is the watermelon that was cut in half on the top, taken out, and then the bottom was cut out at a 45-degree angle. So how does this look like? Let's call this a radius of 2 again. And from the negative z-axis, we have this angle of pi over 4. And then clearly you can see the top part is cleared out. So we want to know our rho limits, our phi limits, and our theta limits. And here is the picture that we have of that watermelon. We're only going to be concerned about this top part. Remember, we took this bottom part out, and so whatever's left up there is the solid that we're interested in. Okay, that's your quiz.